Okay, so here's the link for the Get Body Smart. I would make liberal use of this website. I'm going to give you just a quick run through of it. So the first part of the website is really I'm going to go to muscle physiology. So the first part is really talks about what we've already done, and we can actually go through this quickly. You can see what the muscle fibers are, read about it. So when you click on something, it actually pulls it out. So this shows you muscle fiber, but this shows you the fascicle. Remember, the fascicle is just a bundle of muscle fibers. It'll point out the perimysium, endomysium, and epimysium. Okay, so I would go through this several times. It's very similar to the APR and the Connect, but this really lays it out in a different way. So this would be a great way for you to see that. Okay, what we want to go to is the muscle contraction. Okay, so this is going to show that muscle, or the signal coming down the muscle fiber. So there's that signal, coming down the nerve, down the motor neuron. So there's that coming down. And when it reaches the muscle fibers, notice the action potential spread out in both directions. Okay, and then you get a contraction. Okay, this just shows those vesicles fusing with the end of the motor neuron and releasing their neurotransmitter into the synaptic cleft. And then these are those receptors, and that's where the neurotransmitter binds. And when that happens, it allows sodium to rush in. When the sodium goes in, it causes the action potential to continue down the muscle. Remember, it doesn't just continue down the muscle, it also goes down the T-tubules. So this whole section here describes that. When it goes down the T-tubules, you see those little black dots? That's the calcium being released from the terminal cisternae of the sarcoplasmic reticulum. Awesome. Okay. Okay, so now we're picking this up where the action potential has gone down the T-tubules. Here's the terminal cisternae of the sarcoplasmic reticulum. This is where the calcium is going to be released from. So those little black dots, now notice that they're flowing right down here, and they're going to attach to TNC. Okay, when those calciums attach there, that pulls the tropomyosin away from those myosin head binding sites. So see how those are open now? So the calcium attached to the troponin, that troponin pulled the tropomyosin away from the myosin head binding sites. As soon as those are available, the myosin head is going to bind to the myosin head binding site. Okay, so as soon as they do that, see the myosin head binds there? Now, here's this energy molecule, and that energy molecule, when the myosin head binds here, it actually causes this ADP, the low energy molecule, and the phosphate to leave. Okay, so those leave, and then when they leave, it allows the myosin head to pull on the actin. When the new ATP attaches, and it's showing it going back to the mitochondria, when the new ATP attaches, the myosin head gets released, and then these would get covered up again. And then the myosin head has enzymes that break the ATP down into ADP and phosphate. You have to remember that, oops, I don't want that. You have to remember that the ATP is the high energy molecule. I can't write on this one. ATP is the high energy molecule, where ADP is the low energy molecule. Okay, and this is going to show that happening. So you can see the myosin head's pulling. Okay, and they continue to do that. That's how we sustain a contraction. This is showing the myosin head binding, and as soon as the ATP attaches, you see that the myosin head is released. Okay, calcium goes back into this terminal cisternae. Myosin reblocks the myosin head binding sites, and the ATP is broken back down. Okay. So I would go through this several times if I were you.